Okay, so today we're going to be talking about dependent probability. So we already talked about what it is, but let's just refresh our memory. So dependent probability is when the outcome of one event does affect the outcome of another event. So remember we talked about, I had a jar of blocks, remember? And let's say I wanted to find the probability of getting a green block and then a pink block. Okay, so if I was to draw a green block and leave it out, that now has affected the probability of getting a pink block because now there is one less block in there. So remember, dependent probability is when something happens, you do not replace it. By taking that out, I have affected the probability of getting a pink block. By leaving something out when it affects the probability of something else happening, then that is dependent probability. So let's go ahead and let's do some examples, because as we get through more and more examples, I think you'll get the hang of it a little bit more. So we are still going to be multiplying fractions just like we did in independent probability. So we're still going to have, if there's two events that are happening, two things that are being selected, then that means you're going to have two fractions that are multiplied together. If there's three things that are happening, three events, three things that are being selected, then you'll have three fractions, okay, and so on and so forth. But most of the time we'll just have two fractions. So let's look at number one. Neil goes to the pet shop and selects a treat for his dog. He chooses one, does not replace it, and then he chooses another. What is the probability he selects a bone and then a ball? So looking at our picture here, you will not always have a picture, but when you do, it helps, I think, because I'm going to show you when we are getting ready to write out our fractions, it's going to help us to actually physically take out whatever he chooses first. So he wants to know what is the probability that he's going to get a bone and then a ball. So let's look at, we're first going to find the probability of getting a bone. So let's look at how many bones are there. 1, 2, 3 bones out of how many total? 1, 2, 3, 4, 5, 6, 7 total items. 3 bones out of 7 total items. What we're going to do now is we are going to take out one of the bones because it says he does not replace it. He chooses a bone, he does not replace it. So that means he takes the bone out and he leaves it out. It is gone now. So when that happens, it says then we want to know what is the probability then he selects a ball. Then now by taking that bone out, we have one less item when we're getting ready to write our probability. It's going to be a little bit different. We're not going to have 7 total items anymore. We're going to have one less. We're going to have 6 total this time. So when we're doing dependent probability, the numbers on the bottom of your fractions are going to be different because when you take something out and you leave it out, when you do not replace it, that has affected the total number of items, total number of outcomes. So when you select a bone, there's 3 options out of 7 to select a bone. So he selected a bone, he took it out, it's gone. Now we want to know what is the probability of getting a ball. So now there's only 2 balls. There was 2 balls to begin with, so that really doesn't change. So there's always been 2 balls, but now there's only 6 items. 1, 2, 3, 4, 5, 6. So do you see how that is different than the other problems we did? Because in independent probability, the numbers on the bottom were the same. When we have dependent probability, the numbers that we have on the bottom are different. So let's go ahead and look here. 3 times 2 is 6. 6 times 7 is 42. And remember, once you find the answer, you always want to make sure you can simplify. So this can be simplified down by 6, and that gives us 1 over 7. So that is the probability, the dependent probability of getting a bone and then a ball. Okay, number 2. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? So do you see anywhere that it says she does replace it or does she not replace it? It does not say anywhere she does or does not replace it. So if it says she's choosing one candle and then choosing another candle, it does not say she puts it back. It does not say she puts it back. So we have to assume it is dependent probability that the first candle is staying out of the total. Okay? So we're going to find the probability that first she chooses a polka dot candle out of what they were given at the beginning. So we have 2 polka dot candles out of 5. But again, it does not say she replaces it. So we have to assume that she takes out the polka dot candle that she chose first. We have to assume that she takes that out and it is gone. So if she takes that candle out and now it is gone, then when we're getting ready to write our second fraction, our total is going to be affected because now there's only 4 candles. So if she wants to select a polka dot candle the second time, there's only 1 option for a polka dot candle out of 4 total options. So now that is very different. Okay, so there was 2 polka dot candles out of 5. We took 1 out, so now there's only 1 polka dot candle left out of 4 total outcomes. So top times top, bottom times bottom. 2 times 1 is 2. 5 times 4 is 20. We can simplify that down by 2 to give us 1/10. Awesome. Okay. For these next problems, we are going to be talking about cards that are turned face down. There's 10 yellow cards, 6 green cards, 9 orange, 5 red, and it's saying you're going to select 1 card. You are not going to replace it. It is not replaced. So we're going to be finding these probabilities. So again, we said you will not always have a picture to look at to physically cross out what you're taking out, but since we are learning, since this is the first time we are doing these kind of problems, I went ahead and drew out some cards so that we can physically see what's happening. So we can take the 1 out so we can actually see what's happening. So there are 10 yellow, 6 green, 9 orange, and 5 red. So we always want to first know what is the total number of cards. So it didn't tell us the total anywhere. So we need to go ahead and add up. That's what I always like to do before I get too far into my problem. I always want to know how many total items are there, how many total cards are there. So if we add all these up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I always want to know how many there are total. So there's 30 cards total. So first thing we want to do is we want to find the probability of this P, means probability of drawing 2 yellow cards. Remember, we're taking 1 out. It is not being put back. It's taken out and it stays out. Then we want to find the probability of getting another yellow. So let's first find the probability before we take anything out. What is the probability of getting a yellow card? So there are 10 yellow cards. 10 yellow cards out of 30. Okay, so that's our first probability. But we said we are going to take 1 out and it's not going to be put back. So I'm not going to cross it out because I don't want it to affect the picture for the rest of the problems. But I'm going to take this one out. Okay, this one is gone. It is gone. So how many cards are there now? If I take that 1 yellow out, there are only 29 cards. I took 1 out. So now when we get ready to find the probability of getting a yellow the second time, there are only 9 yellow cards out of 29 options. So that is going to be our second fraction, 9 out of 29. Because remember, do you see when you take this one out, that affects the probability of yellow and it affects the total. Okay, so just for time purposes, I just want us to set up the problem, go ahead and show what we would multiply, but then I want us to stop there because it's going to add more minutes to this video if we went ahead and solved it and simplified. So let's go ahead and do number 4. So probability of getting 2 green cards. So again, here's our cards. We know we have 30. So let's count up how many green cards we have. 1, 2, 3, 4, 5, 6. So we have 6 green cards out of 30. So remember, we are going to take one, we are not replacing it, and then we're going to find the probability of getting another green. So if we take this green card out, then we need to look at how many more do we have left. 1, 2, 3, 4, 5 out of, now there's only 29 cards. So there's only 5 green now out of a total 29 cards. All right, very good. Number 5. Probability of getting a yellow card and then a green card. So again, let's go back to yellow. So here there's 10 yellow cards, so that's going to be our first fraction. Probability of getting a yellow card is 10 out of 30. Okay, so we're going to take a yellow card out and not replace it. So here we go. So now we have 29 cards. Okay, so then we want to write out the probability of getting a green card. So we know there are 6 green cards out of 29. So that's our next fraction. 6 green cards out of 29. All right, very good. Last one, number 6. A red card and then an orange card. So let's look at how many red cards there are. There are 5 red cards out of 30. So after you always write the first probability, take one out, and then the probability of getting an orange. So there are 9 orange cards, 9 out of 29. Oops. All right, very good. So if you are not given a picture, it always helps to, if you want to draw a rough sketch of what you're looking at so you can physically take one out, see what's happening. I would suggest doing that, but if you don't have to, if you can do it all in your head, that is good too. So you won't always have a picture. So last couple questions. So we are now talking about marbles. We've got a bag that contains, or marbles and beads. A bag contains 15 beads. 6 are black and the rest are white. 2 beads are drawn at random. 1 is selected and not replaced. So again, that's telling you it's dependent probability. 1 is taken and it's not put back. So here is our picture. Hopefully, I'm going to put it up here so we can see it better. Okay, so we're going to find the probability of getting 2 black beads. Okay, so we have 15 total. So I showed you what our picture is going to look like. It told us that 6 are black and the rest are white. So if you were to just have the words and you did not have a picture, you would have to do 15 minus 6 and figure out how many white there would be. So I'm going to go ahead and write it all out. We have a total of 15 beads. 6 are black. And then we're needing to figure out how many are white. So 15 minus 6 is equal to 9. So we need to know that there are 9 white beads. Okay, so once we know that, let's go ahead and write out our fraction. So the probability of getting 2 black beads, and remember it is not replaced. So there are 6 black beads out of 15. Okay, so let's take one out. I'm going to take this one out. So we want to know the probability of getting 2 black. So this is the probability before we take one out. We'll take this one out. So how many black beads are left? 1, 2, 3, 4, 5 black beads are left out of a total of now 14. So that is what we would multiply. All right, number 8. The probability of getting 2 white beads. So we know that we figured out there are 9 white beads to begin with. 9 out of 15. Okay, we are going to take one out. It is not replaced, so we'll take this one out. So now the probability of getting a white bead is 2, 3, 4, 5, 6, 7, 8 out of 14, because now that one is gone. All right, and lastly, getting a black bead and then a white bead. So there are 6 black beads out of 15. Take one out. And then the probability of getting a white bead, there are 9 white beads out of 14 total.